Okay, so this is kind of showcasing for the first example on Canvas showing how to do step 3. This is our triangle right here. And the issue is how do we compute dx once we have the triangle set up. So I'm starting off assuming that I have the triangle set up. And now the first thing that I said in the video was you need to look at that you want to find a relationship between x and theta. That's very simple. Okay, there are 6 relationships between x and theta. Why are there 6? Because we've got sine, right? We've got each of these gives us a different relationship, right? If we look at sine theta, cosine theta, so let's go ahead and write out all of the relationships. The key is that some of these relationships are easier to work with than others, right? So that's how we're going to figure out which relationship to use, because there are always going to be 6 relationships because there are 6 trig, 6 different trig expressions. And of course, like any 2 of these trig expressions will give you the other one, right? So if you have sine and cosine, then you can get tan. And if you've got sine, that means you can get cosecant and secant. So any 2 of these really, does it. Sine and cosine, or cosine and tan, right? So 2, hopefully you know what I mean by that. Like for instance, if you have sine and cosecant, that's not going to get you all the relationships because cosecant is just a different version of sine. So if you have sine and cosine, that works, or cosine and tan, that works. But let's just go ahead and write down what are the relationships using the triangle. Okay, so sine of theta is, so I look here, sine of theta is opposite, oh, I need to make that smaller, opposite over hypotenuse. So let me just write this down, opposite over hypotenuse. So that's going to be opposite root 3 over x. Cosine is going to be adjacent over hypotenuse. So that's going to be root x squared minus 3 over x. Tangent is going to be opposite over adjacent, which is root 3 over x squared minus 3, square root of that. Secant, so I need my, what's secant? Secant is, I think of secant as 1 over cosine of theta. So that's just going to be the reciprocal. Thank you. That's going to be the reciprocal of cosine. So we'll get x over the square root of x squared minus 3. Cosecant is the reciprocal of sine theta, which will be x over square root of 3. And cotangent is the reciprocal of tangent. So that's just going to be the square root of x squared minus 3 over square root of 3. Now, we've got all these different relationships, and the question is, which one makes it easy to compute dx? Right, so let's look at this first relationship. With this first relationship here, the first one we have, which is that sine theta equals root 3 over x. Let's just rewrite that over here in a different color. So we write that as sine theta equals root 3 over x. Now it's easy for me to solve it and say, okay, that means x is equal to root 3 cosecant theta. So now dx is going to be root 3 negative cosecant theta cotan theta d theta, right? If we have cosine theta, well, now look at this. This is going to be quite, this relationship is, this is just as valid as the others, but this relationship is now square root x squared minus 3 over x. And I could take the differential of both sides, right? And I would get, with that negative sine theta d theta equals, and I would need to take the derivative of this and then tack on a dx. That's long, and I'm probably going to make a mistake because it involves a lot of computations. So like I'm not even going to do that because, you know, no one would do that. With the tangent, what do we get here? So with this, we've got tangent of theta is equal to root 3 over square root of x squared minus 3. Again, I could, you know, get secant squared theta d theta equals, and then over here I would get root 3. Now this is, let's just look at this. So if I've got, this is essentially x squared minus 3 to the negative 1/2, right? So now I would get negative 1/2. I want the differential of this. So I get negative 1/2 x squared minus 3 to the negative 3/2 times 2x. So the 2's would cancel out, and then I'd have a dx. So I would have this, and then I'd have root 3 x over x squared minus 3 to the 3/2 dx. Can you see already how this relationship here is more complicated than this relationship here? Right? It's easier to go from x equals, because what did I do over here? I start off with sine theta equals root 3 over x, and then I rewrote it x equals root 3 cosecant theta, right? Dx equals blah, blah, blah. It's kind of short, it's clean, whereas this has a d theta and a secant squared, and now I've got to hope that this part right here is in my original integral, right? Because remember, all I wanted was to find dx. My goal was to find dx. So I would actually have to take this x over x squared minus 3 to the 3/2 and divide both sides by it, and, you know, it'd be a real mess. This one was so long, I just didn't even bother to try to do it. Okay. Notice over here, if we look over here at the secant theta is equal to x, this one is going to be long and complicated, just like cosine is, right? So secant and cosine, too long. We're going to skip over it. What about the cosecant? Do you see how this one is nice and easy? So for cosecant theta, we've got cosecant theta equals x over root 3. This one is lovely. I can just take the differential of both sides, and I would get negative cosecant theta cotan theta d theta equals, and then I just get 1 over root 3 dx. So then dx is going to be multiply both sides by root 3 cosecant theta cotan theta d theta d theta. Right, so this one is nice and easy compared to the other ones. And it's nice and easy because this is just the reciprocal of this one right here, the sine, right? So the relationship, so what we're saying is essentially is if this is a relationship between x and theta, if the relationship between x and theta is modeled by this triangle, then dx is equal to square root of 3 or negative root 3 cosecant theta cotan theta d theta. Okay, so how do we compute dx once we have the triangle set up? Well, we compute it by looking, or in our mind, we kind of think of the different relationships between x and theta. And to me, looking at this, I don't want to include that leg because it's just complicated. The square root of x squared is complicated. It'd be a lot easier for me to find a relationship with this constant and just x. And the relationship that will do that is either sine theta or cosecant theta. Both of those work. Okay. So now let me see. I think it might be good for me to do just one more example. Okay, I'm going to do just one more example. This hopefully is, going to be kind of enlightening. So we're going to do the setup. This is essentially, we're working on doing step one. So this is the setup for the following integral. This is the integral of, let's say, x squared, a squared minus x squared, square root of that, dx. And so here a is a constant. Okay, so we're going to do step one, which is to create our triangle, label our triangle, and then rewrite everything from x's into something involving thetas. Okay, so let's get our triangle set up. Now, again, because I've got my radical here is this square root of a squared minus x squared, I'm looking at that, and that's definitely going to be the length of a leg, right? So this is not going to be a hypotenuse, not a hypotenuse. Because remember, a hypotenuse needs to be like something squared plus something squared, square root like that, right? So if we've got something squared minus something squared, that's not a good candidate for a hypotenuse. That's more a candidate for a leg. So this will be square root of a squared minus x squared. Now I think, what would I need to complete my right triangle in a good manner? So if I've got this, right, so this squared plus something squared equals my hypotenuse squared. That's what I'm thinking in my mind. Now, what is the square root of a squared minus x squared squared? Square root and squared are going to cancel each other out. Right, so see this square root and then squared, they're going to cancel each other out. So this first one is just going to end up a squared minus x squared plus something squared equals my hypotenuse squared. Well, now it's kind of clear to see that I should put an x here. And then for my hypotenuse should be a, right? So that's what makes it work. So here, I'll put an x, and my hypotenuse is a. Now, once I have my triangle set up, we can erase this. Got my triangle set up here. Can also erase that. So I've got my triangle set up. Now, what I want to do is convert each part of my integral from stuff in terms of x to stuff in terms of u. Right, so this is the stuff in terms of x and dx is now going to be converted to stuff in terms of u and du, or sorry, theta and d theta. Okay, so I've got this x squared and then the square root of a squared minus x squared dx. I'm going to look at my triangle, and I'm just going to put in a theta down here, and I'm going to just write down some of the relationships between x and theta. So what is sine theta? What's cosine theta? What's tangent theta? What's secant theta? Cosecant theta? And cotangent theta. So this is all what I'm doing in my head, or you can write it down. Nobody cares if you write it down or if you do it in your head, no problem. Right, to figure out which relationship you want to use. Okay, so sine of theta is going to be x over a. In my mind already, I know this is going to be perfect for computing my dx. In fact, let me go ahead and do that now. So this means that a sine theta is equal to x So then dx is going to be a cosine theta d theta. I know that I have a dx that I need to convert, so I can go ahead and do that over here. Dx is going to be equal to a cosine theta d theta. All right. Now what else do I have? I've got an x squared and a square root of a squared minus x squared. Okay. What is cosine of theta? Cosine of theta is going to be square root of a squared minus x squared over a. Bam. I'm going to use this. This one is going to be used for that part right there, for that part of the integrand. So because of this, this means I can just multiply both sides by a. Do you see what I'm doing here? Multiply both sides by a. The a's cancel out. And so I've got a cosine theta is equal to the square root of a squared minus x squared. And isn't that what I needed? Square root of a squared minus x squared. So bam, square root of a squared minus x squared is equal to a cosine theta. And now we still have an x squared, right? So how are we going to get x squared going? Let's look at tangent. Tangent of theta is x over a. Lovely. I can use this relationship for x squared because according to this, multiply both sides by a. Right, the a's cancel out. So a tan theta is equal to x. So that means that x squared is a squared tan squared theta. Okay, so my x squared is going to be a squared tan squared theta. So I don't even need to go any further, right? I don't need to go any further with figuring out the relationship between secant, cosecant, and cotangent because I've rewritten every part of my original integral, right? The x squared, the square root of a squared minus x squared, and the dx. I've rewritten them in terms of theta and d theta. So to go ahead and let's see here. So our step one, the conclusion of step one is to say that the integral, let's go ahead and make this a little larger. The integral of x squared, a squared,
9:15.
square root of that, dx, is equal to the integral. Now instead of the x squared, I'll have a squared tan squared theta, right? And now let me replace this square root of a squared minus x squared with a cosine theta. And then my dx is a cosine theta d theta. A cosine theta d theta. And so, of course, I can combine some of these terms, and I'll get a to the fourth power. So we've got an a squared, a to the fourth power. And then tangent squared, theta, cosine squared theta, d theta. Okay, so this is a trig integral. And if we were to solve this trig integral, we would say, how do you solve trig integral? Right, so step two would be solving the trig integral. Also, let me make it very clear that for step one, this little triangle is imperative because this tells us what theta is, right? If you just have this written down without, right, if all you write down is this little relationship right here, no one knows what you're talking about because I don't know what theta is. Once you include this little triangle, oh, now I know what theta is because you tell me what theta is by giving me this little triangle. And this now is a complete step 1. Okay, now step 2 is to evaluate the trig identity. The trig integral. So we've got a to the 4 times the integral of tan squared theta, cosine squared theta d theta. And the first thing we think is, hey, wait a minute, tangent and secant go together. Sine and cosine go together. Tangent and cosine, they don't really go together, right? So what can we do? Well, actually, let's go ahead and we can rewrite tan squared as sine squared theta over cosine squared theta, right? And then times our cosine squared theta d theta. Now, the cosine squared thetas cancel out, and we've got a to the 4th power integral sine squared theta d theta. What is the integral of sine squared theta d theta? Well, we've got to know that to compute the integral of sine squared theta d theta, it's not a trick, but here's how we do it. We go back to those original trig identities, and I'm flipping in my book now. Like, this would be a perfect thing to have on your little note card. Sine squared of theta is equal to, so this is your half angle formula. Sine squared says sine squared theta is equal to 1 minus cosine 2 theta over 2. So we'll have a to the 4th times the integral of 1 minus cosine 2 theta over 2 d theta. And now we say, okay, this is the integral of 1 over 2 minus cosine 2 theta over 2 d theta. And a to the 4th, we've got the integral of 1 over 2 d theta minus the integral cosine 2 theta over 2 d theta. Now, the integral of 1/2 d theta is just going to be theta over 2. And the integral of cosine 2 theta, integral of cosine 2 theta over 2 d theta. I'm going to let u equal 2 theta, du equals 2 d theta. So d theta is equal to 1/2 du. So this is going to equal the integral 1/4 cosine of u du, which is 1/4 sine u, which is 1/4 sine 2 theta. So minus 1/4 sine 2 theta plus a constant. Okay. And then step 3, well, actually, let's go ahead and write down here. Our conclusion is that a to the 4th